Welcome back. I just realized after I cut down video one that there was still one problem left from chapter one. So we're going to pick it up on this video with our last problem, number 10 from chapter one, and then we'll move into the problems from chapter two. Let me get you to the visualizer here. Okay, on top of your screen, you can see that we're still going to look at the solution for problem 10. Uh, you know that a question where we either worth 3 points or 5 points, and they scored a total of 44 points and they answered 12 questions. I went after this one as a system. I let X be the number of 3 point questions. I let Y be the number of 5 point questions, and that generates for us a system of two equations and two unknowns. So if we add the number of questions of each point variety answered, we get 12 question answer total. So X plus Y has to be 12. Second equation uses point value. So each of the X's were worth 3, each of the Y's were worth 5, and the total points scored were 44. I think the easiest way to solve that system is by elimination. So I chose to multiply the first of those two equations by -3. And that's how you see the -3x minus 3y is equal to -36. And then if I add, the X's will drop out, they'll eliminate. Leaves me 2y is equal to 8. Remember, you're adding the -36 and the 44 on the right side of that equal sign. Y is 4, halfway home. Use your 4. I use the first equation that says x plus y is 12. We now know y to be 4. So if you let me put 4 in there, I'll realize that x is 8. And therefore, I would have answered 8 3-point questions correctly and 4 5-point questions. Moving in to chapter 2. 11 asks you to list all the subsets of a set that contains 4 elements, A, B, C, and D. So the first thing you see there are the sets that have only one element, set A, set with B, a set with C, a set with D. Then I listed all of the sets that could have 2. You can have A with B, you can have A with C, A with D, B with C, B with D, C with D. Remember, order doesn't matter. Okay, excuse me. Then I listed the sets that have 3 of them, A and B and C, A and B and D, B and C and D, A and C and D. The last 2 are the ones you got to keep awake. Every set is a subset of itself. So you'll also list the full set, A, B, C, D, and you'll list the empty set, which is also a subset of every set. So we should have 16 subsets, and we did. Okay. Now we got some set things to deal with. So I'm going to refer back to the problems that you've printed. Part A asks, what's the cardinality of set A? And that just means how many elements are in set A. Set A has the letters R, A, V, and E. So it has 4 elements. So the cardinality for that set is just 4. Part B says, why don't we do the values that are in the union of A or B? All right, so you're going to list everything that's found in set A or set B. As it turns out, everything that's in set A is already in set B. So it's just R, A, V, E. All right. Part C looks like it's an intersection. What's in set C and in set D? So now it's more restrictive. These elements have to be found in both sets C and D. The 2 elements that are found in both sets would be L and E. Part D says, let's do the complement of set D. Now you must refer back to the universal set to help you. So the question is, what's in the universal set that is not in set D? There are a lot of things not in set D. Pepperoni pizza is not in set D, but you won't list it. You're restricted by the universal set. So what's not in set D from the universal set? U, N, I, V, and R are the values that are in the universal set but are not found in set D. Okay, I used D complement there, which we did in part D, to help us do part E. And part E says, why don't we do another intersection of the values that are found in set A and in D complement, which happens to be our answer for part D. And the 2 values that were common to set A and D complement were the values R and V. Okay, part F asks us to do the union of B or C intersected with D. So for our purposes there, I chose to go ahead and list the values that are in the union of B or C. And it's a pretty extensive list. It's got A, R, E, L, I, and N. And now you must look at the values that are in that set and in set D. And that I believe would just be A and L and E. So our correct answer for part F is just A and L and E. Switching out answers. Still working on sets. Okay. Part G. What can you find that's in the intersections of C and D and A? All right. So we're looking for intersections of C and D and A. So you're looking for elements that are common to all three of those sets. I think the only one that is E. Part H says start with A and take away B. So you'll start by listing the elements that are in A, that's R, A, V, and E, and you will eliminate anybody who's found in B. So you'll eliminate an A, you'll eliminate an R, you'll eliminate an E because those are the members of set B. And that just leaves the V. The last one is Cartesian product. Remember, Cartesian products are ordered pairs. So your first entry in the ordered pair comes from set B. Your second ordered pair in the your second entry in the ordered pair, I should say, comes from set C. So you list all the possible ordered pairs you can, where the first component comes from B and the second component comes from C. And there they are. There should be, looks like 12 of them. A with L, A with I, A with N, A with E. Then you switch it out. You've used A with everybody. So you pick up R with everybody. And you pick up E with everybody. And you are done. Okay. That's Cartesian product. 13. You're playing a word game, got 5 distinct letters. The question is, how many ways can you put them in order? You can pick 5 choices for your first letter, but once you've picked a choice for your first letter, you only have 4 choices for your next letter. Then you have 3, then you have 2, and then you have 1. The answer is the product of those. So it's 5 times 4 times 3 times 2 times 1. You guessed it, that's 120 arrangements for your 5 letters. 14. The challenge is to, first of all, pair them up in a one-to-one correspondence. I've listed just one such one-to-one correspondence. You just have to match everybody from set C with somebody from set D. You don't have to match Y with S. You could be a rebel and match Y with E if you wanted, but you match one-to-one. Question says, part B, how many of those one-to-one correspondences are there? So when you chose to match somebody with Y, you had 4 choices. So your first entry in that answer is 4. But then once you match up Y with somebody, you only have 3 choices for your next guy. And then 2 choices for your next guy and 1 choice for your last guy. So it's 4 times 3 times 2 times 1, 24 possible correspondences on the one-to-one. Very similar to what we had going on number 13. Okay, Venn diagram action. Remember, you want to start working from the inside out. So the most important number there is the 3 people who studied all 3 subjects. All right, and you can't be too literal. Yeah, I know the problem says that 7 people liked history and mathematics, but remember, when you're sliding that football shape, that's the intersection of history and mathematics, you can't put a 7 because the 3 that you put in the middle constitutes 3 of that 7. That's how the 4 got in there in the football shape for history and math. Similarly, 2 people in the little football shape studied history and English, didn't have math. 5 people studied math and English, didn't have history. All right, and then again, don't be literal here. Just because Dell typed 16 people took history, don't put 16 somewhere in that history circle. You've already accounted for 4 and 3 and 2 in the history circle. So you've already accounted for 9 people. So take 16 and take away 9. That's where that 7 came in. In a similar fashion, all right, the problem says that there are 18 people who like math. You've already accounted for 4 and 3 and 5. All right, so you've already accounted for 12 people. So 18 minus 12 is how that 6 got in the math circle. Similarly, you got 9 for English. And then it said somewhere in the words that there are 4 people who didn't like any of them. And then once you get the Venn set up correctly, you got a fighting chance to answer the questions. So sadly, I'm going to try to keep the Venn on the visualizer and see if I can pull this off. show you the numbers that got involved in the addition for the parts that we still have to look at. If I slide up a little, maybe. That's a good try. All right. Part B says how many students, and that means you're just going to add everything that you see anywhere on that Venn diagram. So that's going to be 7 plus 4 plus 3 plus 2 plus 6 plus 5 plus 9 plus 4, and that's 40 students total. Part C says how many people liked at least 2 of the subjects. So you'll see that these 4 and these 3 and these 2 and these 5 all liked at least 2. So we'll be adding those numbers, 4 plus 3 plus 2 plus 5. That's 14 people liked at least 2 of the subjects. Last part says how many people liked English and math, but didn't like history, and that's just 5. And that takes care of our Venn diagram problem. And let's move forward. Oh, you know what? Let's shut down the video. We'll pop up video 3 as we begin chapter 3. See you soon.